All right, assalamu alaikum everyone. I hope you guys are all doing well. Let's begin. So we were doing trigonometry, and today we are going to be doing one new concept. And I actually asked you to do some questions like this in the last class as well. Not sure if I told you the question numbers or not. Or at least this was one question that I asked you to do, question number 43. I hope you had the chance to have a look at that, attempt that. We will be discussing questions like these today, inshallah. All right. Okay. Can someone please confirm if you can see my screen first of all?
Yes, sir.
All right, good. Okay. By the way, if any of you enrolled in that M1 course and hasn't yet been added to the M1 group yet, do message me about it, please, in case I've missed you there. Abdullah, I think I've added you now. I had forgotten with your name I had only P1 written earlier, but I've corrected that now. I think now it's everyone added. Okay. All right. So we were doing trigonometry and we were done with a number of concepts on this topic already. In the last class in particular, we talked about how to solve equations involving angles that have something other than theta or x inside brackets like this. Okay. If you have theta plus 60, x plus 6, x plus something, x minus something, 2 times theta, 3 times theta, we looked at how to solve equations like these. All right. Using substitution. You need to remember to adjust the interval like this. And then at the end, you put that substitution back to find any unknowns that you have there. That's what we looked at yesterday. There was one question that we did in gradients as well using this. So yeah, that was what we did in our last class. Now today we want to do one new concept, and that is how to solve questions like these. For example, this is question number 43 from the worksheet. So sometimes what happens is in the question, they give you one function like sine, cos, or tan. In this case, for instance, they've told you that cos of x equals p, where x is an acute angle in degrees. And what you have to do is you have to find in terms of p sine x, and tan of 90 minus x. That's what you want to find using cos of x equal to p. This is what we want to learn today. There are some complications that come in problems like these as well. We'll be looking at a number of questions similar to this and understand how to deal with all of them. But before that, just to get an idea, do you have any other questions from the worksheet in which you had problems until this point? Apart from the graph questions, we haven't graphs yet. But apart from graphs, do you have any other problems from any questions on the worksheet? Anyone? Any trigonometry questions? No. Okay, so after today, you should be able to do all questions from this worksheet apart from the ones that involve sketching graphs. Okay, apart from those, you can do the rest of them because we have covered all the other concepts. We would have covered all the other concepts after this class. Okay, so I would expect you to spend this weekend practicing a lot of questions from this worksheet. So you should start with the assigned questions, make sure that you complete all of them, and then look at some recent questions as well from any topical book, 2020, 2021, 2022, questions from these papers. You will start from the assigned questions first, because once you've done them, that will cover pretty much everything that you need to know in terms of concepts. But then for more practice, you will be looking at some recent questions papers, some recent papers questions, okay? All right, so let's have a look at the next concept then. Question number 43, let's try to understand this next concept using this example, and then we'll do some more variations of this as well. So we have cos of x equal to p given in the question. And using that, what you have to do is you have to find the value of sine x. And they've also told you that x is an acute angle. If x is an acute angle, that means it's between 0 and 90 degrees. And therefore, it's going to be in the first quadrant. If it's an acute angle, it's in the first quadrant. And in the first quadrant, remember, sine, cos, and tan, all of them are positive. Now, how do you find the values of sine, tan, and tan of 90 minus x? One idea is that we use identities, right? Let's start with that first. Using identities. What are the two identities that we have done? We have done sine square theta plus cos square theta. That's identical to 1. That is one identity that we've done. And another one is tan theta identical to sine theta over cos theta. These are two different identities that we have done in our syllabus until now. Now, can we use these to find sine x and tan x somehow? We know that cos x equals p. That's what we are given. So if we use this identity, the first one, we can say sine square x plus cos square x, that should equal p, right? Now, since we know the value of cos x, cos square x will be p squared. So this becomes, I'm sorry, this is supposed to be 1 on the right side. Sine square x plus cos square x, that is equal to 1. Now, sine square x plus cos square x, in place of cos square x, we can put p square, that equals 1. And then take p squared to the right side, and it becomes sine square x equals 1 minus p squared. You can now take square root on both sides, and that gives you sine of x equals 1 minus p squared. But remember, whenever you take square root, you always have to put plus minus, unless there's a reason not to. You put plus minus, but remember, x is supposed to be an acute angle. That means x is in the first quadrant. If x is in the first quadrant, sine is supposed to be positive. Because of that reason, that x is in the first quadrant, we only consider the positive sign here, and we say the value of sine x therefore should be square root of 1 minus p squared. That's what you wanted to find out, right? Sine x equals 1 minus p squared square root. Okay. Now the second part says find tan x. How can you find tan x now? Tan x is defined as sine x over cos x. Okay. Tan x equals sine x over cos x. Now we have already found the value for sine x, that is 1 minus p squared square root. We know cos x as well, that is p. So tan x is just equal to this. Square root of 1 minus p squared divided by p. All right. Now, what about the third one? We want to find tan of 90 minus x. Now, what does that mean? Tan of 90 minus x. We haven't really done anything like this before, right? Tan of 90 minus x. Let's try to understand this now. Now, first of all, we are going to try and do this using another set of identities that are not given in the formula sheet, but you will need to know them. It's not necessary to know them for this topic, but eventually you'll find out for some other topics later on, not in P1, but maybe in M1 and definitely in P3 later. You will need to know those identities, so you might as well learn them right now, and they will help you in paper 1 as well. So these new identities that are not given in the formula sheet, in fact, I think you might have done these in O-levels as well. Some teachers teach these in O levels as well, although they're not part of the syllabus explicitly, but I think some of you might have already seen them before. These are called complementary angle identities. Complementary angle identities. What are complementary angles? Complementary angles are those angles that add up to 90 degrees. So for instance, if you have 20 degrees and 70 degrees, these are complementary angles because the sum is 90. There was another terminology like this that used to use in O levels. That was in cyclic quadrilaterals. That was supplementary angles. Don't confuse it with that. Supplementary angles are angles that add up to 180. Complementary angles are angles that add up to 90. Okay. Now, there's something interesting about complementary angles as far as sine cos functions is concerned. For example, try this on your calculator. If you try sine of 15 and cos of 75, you would find that they're both the same. If you try cos of 30 degrees, that is equal to sine of 60 degrees. And any other combination of angles in which the angles add up to 90, if you were to find sine of one of those angles, that will be equal to cos of the other angle. Okay. Whenever two angles add up to 90 degrees, sine of one of them is going to be equal to cos of the other. All right. Now, why is that? Let's try to understand that. Let's make a right angle triangle. Let's say we have a triangle that looks like this. Okay, so we have this right angle triangle. In this triangle, one angle is of course 90 degrees. Let's say this is 9. In fact, this is 90. Let's say this is theta. If this is theta, can we say anything about that other angle? The angle that's left? The total angles, the sum of all angles in a triangle is 180. So we subtract from 180, 90 and theta. What does that leave us with? 90 minus theta. So this angle that you see on top there is 90 minus theta. If this is theta, that other angle is going to be 90 minus theta. Okay. Now, if I were to call this side A and this side B and this side C, what is sine of theta? Sine of theta is opposite over hypotenuse. That will be B over C. And then what is cos of theta? Cos of theta is adjacent over hypotenuse. That's A over C. And then what is tan of theta? Tan of theta is opposite over adjacent. That's B over A. If we find the same three ratios for 90 minus theta now, what is cos of 90 minus theta? So cos of the angle that you have on top there, on top right, what's the cos of that angle? Adjacent side is B, hypotenuse is C. Cos of 90 minus theta is B over C. What about sine of 90 minus theta? Opposite side is A, hypotenuse is C. That gives you A over C. Okay. And then similarly, what about tan of 90 minus theta? That's A over B, because the opposite is now A and adjacent is B. So tan of 90 minus theta is equal to A over B. Now, can you see the relationship between all of these now? These two values are the same. These two values are also the same. And what about these two? They are reciprocal of each other. All right. From this, we get three identities. And those identities look like this. Sine of 90 degrees minus theta is equal to cos theta. Cos of 90 minus theta equals sine theta. And tan of 90 minus theta, what is that? That is equal to 1 over tan theta, because these two are reciprocals of each other. Tan 90 minus theta and tan theta, they're reciprocals of each other. So we have these three identities that we now need to remember. They are not given in the formula sheet. You should memorize them. Okay. Sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. Tan of 90 minus theta is 1 over tan theta. All right. If you were to write down these same identities in radians, they would look like this. I could just copy them. In radians, 90 degrees is pi over 2. So these identities are going to be sine of pi over 2 minus theta. That is equal to cos theta. Cos of pi over 2 minus theta. That is equal to sine theta. And tan of pi over 2 minus theta. That is equal to 1 over tan theta. These are the three identities that we have in radians. Okay, so you can remember any one of them. These are easier to remember. And then if you want to use them in radians, just remember 90 degrees is going to be replaced with pi over 2, because that's the equivalent angle in radians. These are called complementary angle identities. Why? Because 90 minus theta and theta, they add up to 90. They're complementary angles. This is what you need to know about. Okay, so you need to remember these identities. Now, if you remember these identities, now you can directly figure out what tan of 90 minus theta in that question would be. So let's go back to that question, which is this. In the third part, we were asked to find tan of 90 minus x. What's tan of 90 minus x? We know now this is 1 over tan x. So just the reciprocal of tan. We already have the value of tan. We can just take reciprocal of that, and that gives us p over square root of 1 minus p squared. And that is tan of 90 minus x. Okay, just reciprocal of this. That gives us the result. Any problem with this? Any questions?
Sir, can you please explain it again? Tan of 90 minus x.
We just wrote this identity here. Using this diagram, we calculated tan of theta. That was opposite over adjacent. That's b over a. Tan of 90 minus theta, opposite over adjacent, a over b. You can see clearly these are reciprocals of each other, right? Tan theta is b over a. Tan of 90 minus theta is a over b. They're reciprocal to each other. So we can say tan of 90 minus theta is 1 over tan theta. So we have this identity, which we will now remember. We're just using that identity here. We're saying tan of 90 minus x is supposed to be 1 over tan x. Instead of theta, we've got x here. We already know what tan of x is. That's this. 1 over tan x is reciprocal of that. We just take reciprocal of that, it becomes p over square root of 1 minus p squared. Is that okay?
Sir, but shouldn't be tan 90 minus x be written as 1 over tan into 90 minus x if it is the reciprocal?
No, you're saying tan of 90 minus x equals 1 over tan of 90 minus x. How does that make sense?
Yes, sir.
This is the identity. Tan of 90 minus theta and tan 1 over tan theta. These two are reciprocal to each other. Tan of 90 minus theta and tan of theta. These two are supposed to be reciprocal to each other.
Okay, sir. I got it.
So on one side you have tan, on one side you would have tan of 90 minus theta, on the other side you have tan of theta. This does not make sense. You can't have the same thing on both sides. Okay. All right, that was part 3. No problems. Can we move on? Is this clear to everyone? Okay.
Yes,
Now
sir.
let's discuss another method for this. This is using identities. But you will find in such problems, you will not always be able to use identities because there's many different types of questions that they ask in such problems. For example, they might ask you for sine of pi minus x, or in this case, you could say sine of 180 minus x, something like this. Now we have identities for these as well. We have identities for 360 minus x as well. We have identities for sine of 180 plus x as well, but then that will be too much. That will be too many identities that you would need to remember. So rather than memorizing all of those identities, we're going to think about these logically using a diagram. Okay. So one possibility is using identities that we've done here. There's another way of dealing, there's another way of solving such problems, and that is using right angle triangles. So you make right angle triangles and think about this using that triangle. Now, this is very important because, again, this is a concept that you will use in other papers later as well. You'll be using this in mechanics as well, and of course in paper 3 as well. Now, how does this work? Let's try to understand this. So, and the other way of doing this would be using something like this. We say, okay, we have an acute angle. Which quadrant is that going to be? First quadrant. So the angle X is supposed to be in the first quadrant. Okay. So what we do is we make an angle X in the first quadrant. That looks like this. This is the angle X. What are we given in the question? In the question, it says cos of X equals P. That is what we are given. Cos of X equals P, and X is an acute angle. All right. Using that, we have to find sine of X, tan of X, and tan of 90 minus X. We represent this on a diagram. X is supposed to be in the first quadrant because it's an acute angle. If we make a right angle triangle here in the first quadrant, the angle is X, and we know that cos of X is equal to P. What's the definition of cos? How is cos defined? Adjacent over hypotenuse, or base over hypotenuse, or in our new definition, X over H, whatever you want to use. In this case, in fact, X is the angle, so you should not be using X. You can say this is base over hypotenuse, right? That was the definition of cos, base over hypotenuse. So cos of X equals P is actually telling you that the ratio of base and hypotenuse, base over hypotenuse, that is equal to P. Now, if this is equal to P, we can actually write P as P over 1, right? P is the same thing as P over 1, just like if you have 4 written, that's the same thing as 4 over 1. We can divide anything by 1, it will remain the same thing, right? If we write it like this, we can say the ratio between base and hypotenuse is 1. So if base equals 1, from this we know the hypotenuse should be equal to, so if base equals P, the hypotenuse should be equal to 1, right? If you compare the two. If base is equal to P, then hypotenuse should be 1. That means on this diagram that we drew there, if this side is P, this is supposed to be 1. All right? That's just the ratio. It does not necessarily mean that the length is exactly P and this is exactly 1. It could also mean that base is 2P and hypotenuse is 2. The ratio is the same, right? We're just talking about the ratio. If this is P, then this is supposed to be 1. The ratio is p to 1. Okay. Can we find perpendicular using this? We can use Pythagoras. That will give us hypotenuse squared, that's 1 squared, equals, or let's do the other way around, perpendicular squared plus base squared, which is p squared, that equals hypotenuse squared, which is 1 squared. And from this we get that perpendicular squared equals 1 minus p squared, and perpendicular equals square root of 1 minus p squared. Okay. Now I'm doing a lot of steps here. You can do it mentally as well. You can write in a single line as well. You don't necessarily have to show all of this. I'm just explaining this. I'm writing a lot here. But you can just figure it out in your head as well. You can say that this is supposed to be 1 minus p squared square root. So perpendicular is square root of 1 minus p squared. Once you have done this effort, once for this whole question, now answering all of these three parts is pretty straightforward. So what do you want to answer now? You want sine of x. Okay, sine of x. How is sine defined? Sine is perpendicular over the hypotenuse. We already know those values. Perpendicular is square root of 1 minus p squared. Hypotenuse is 1. So sine turns out to be square root of 1 minus p squared. And since it's in the first quadrant, sine is going to remain positive, of course. Okay. All right. Then we have to find cos of x. Sorry, tan of x. How is tan defined? Tan is defined as opposite or perpendicular divided by the base. What's the perpendicular? The perpendicular is square root of 1 minus p squared. Base is p, so that is your tan. And again, it's the first quadrant, so tan is also positive. Then they ask us for tan of 90 minus x. What about this now? Look at this diagram again. We know that if this is x, what about this? The angle on top there? This is supposed to be 90 minus x. So what is tan of this angle? The opposite side is p, and the adjacent side is this. So tan of 90 minus x, therefore, is going to be p over square root of 1 minus p squared. So this turns out to be p over square root of 1 minus p squared. So this is how you can approach that same problem using a right angle triangle. So you make a right angle triangle there. You know two sides already, because if cos is p, that means the ratio of base and hypotenuse is p. So if base is p, then hypotenuse is supposed to be 1. You can find perpendicular using that. And once you have all three sides, you can find sine, tan, and whatever you want in that triangle. Is that okay?
Yes, sir.
All right. Now let's have a look at a few more questions like these. That's all that we want to do today. Some more practice in this. We'll try 2-3 more questions like this, in which we'll have some more complication. So this was question number 43. Let's have a look at another one from the worksheet. Okay, so this is in radians now, question number 18. Let's try this. Question number 18 from the worksheet. Okay, so again, we have an acute angle, and the angle now is x radians. It is such that tan x equals k, where k is a positive constant. We need to express in terms of k tan of pi minus x, tan of pi over 2 minus x, and sine of x. Okay. Now, again, we think of that right angle triangle. Now, before we actually do this, I just want to remind you about this. When we started trigonometry and we learned how to solve trigonometric equations, there was one thing that we discussed in the process, and that was, one was quadrants, how different functions are positive in each of these quadrants. In the first quadrant, all functions are positive, and then in the second, sine is positive, the other two are negative. And similarly for the third and fourth quadrant, we have tan and cos positive respectively. There was another thing that we discussed, and that was about the basic angle. This was something very important that we used to use for solving equations. Why was basic angle important? It was because whenever the basic angle is the same, the ratio sine, cos, and tan, it turns out to be the same for those angles. It's just a difference of plus and minus. So we looked at this example in which one angle was 30, another was 150, another was 210, then another was 330. All of these angles had the same basic angle 30, right? All of them make a 30 degrees with the horizontal axis. Now, when we found sine of all of these angles, cos of all of these angles, tan of all of these angles, you see, the values of sine turn out to be the same. They're all 1/2. Cos turns out to be the same, under root 3/2. Tan is also the same, under root 3/3. The only difference is some are positive and the others are negative. If the basic angle is the same, the magnitude of sine is the same, cos is the same, tan is the same. Okay. Now keep that in mind. Let's have a look at this. It says acute angle x radians is such that tan x equals k. We're talking about an acute angle. That means the first quadrant. We are here in the first quadrant. X is acute. That's here. Tan of x equals k. So if we were to make a right angle triangle here, we can just find all those sides. They are going to help us at some point in this question. So let's just do that working once, so that whenever it's required, we can use that. We are given tan x equals k, right? That is what we are given. How is tan defined? Tan is defined as perpendicular over the base. This is the definition of tan. So we can say if perpendicular is k, then what about the base? Base is going to be 1. Now, using perpendicular and base, can we figure out the hypotenuse? We can say hypotenuse squared equals 1 squared plus k squared. Then hypotenuse would just be square root of this. So hypotenuse equals square root of 1 plus k squared. So now we know if this side is k, opposite is k, and adjacent is 1, then hypotenuse is supposed to be 1 plus k squared, and then square root of that. All right. So we have all the sides figured out. Now let's see what they've asked us to do. K is a positive constant, so that means, of course, it's the first quadrant. So k was supposed to be positive because tan is positive in the first quadrant. We need to express in terms of k tan of pi minus x first of all. Now, what does that mean? Tan of pi minus x. Where is this angle going to be? Where is this angle going to be? Which quadrant is it going to be?
Quadrant 2.
Quadrant number 2, second quadrant, right? Because remember, in radians, this is 0. This is pi over 2. This is pi. And then this is 3 pi over 2. And then this is again 2 pi. We are doing pi minus x. X is an acute angle. When you do pi minus x, we would be somewhere around here, such that this angle is x, and this angle is pi minus x. All right. Now, what is tan of pi minus x? It's the same basic angle. It's the same basic angle as x. In the first quadrant, the basic angle was x. In the second quadrant, the basic angle is x. Since the basic angle is the same, this ratio is going to be the same as before as well. This is just going to be k. However, since we are in the second quadrant now, tan is supposed to be negative in the second quadrant. So we put minus here. We say this is going to be minus k. Magnitude is the same as before because it's the same basic angle, x. And if it's the same basic angle, remember the triangles are similar. So all the ratios are going to be the same. This is going to be k. This is still going to be square root of 1 plus k squared. And this is still going to be 1. All the ratios are the same. So that means sine, cos, tan are going to be the same as well. The only difference is whether it's plus or minus. Since we are in the second quadrant, tan is negative, we just put a negative sign there. So that's minus k like this. Is that all right?
So wouldn't the base in the second quadrant be -1?
Yeah, so basically -1. So we are talking about magnitude here. So if base is -1, that is exactly why we get minus k here. Yeah, so that's correct. But since we're talking about in a triangle, we're just talking about the length. We just wrote one there. Then we can figure out using quadrants that since tan is supposed to be negative in the second quadrant, we just put negative sign because of that. Otherwise, yes, you can think of this as negative, and then when you do k over -1, you get minus k from that directly, which you can either do using quadrants or like this. That's your choice. Yeah, so that's good. You end up with the same result, nevertheless. Any issues with this? No? Let's look at the second part now. The second part says tan of pi over 2 minus x. What do you think this is going to be? Tan of pi over 2 minus x. If this is x, we could either think of this using the triangle. If this is x, we can say the angle on top here, that's going to be pi over 2 minus x. If we're talking about radians, this is pi over 2 minus x. Just find tan based on this angle. Opposite is 1, adjacent is k. So that's 1 over k. Or alternatively, you could think of that identity. If you find this confusing, for this, you could use that identity. Tan of pi over 2 minus x is 1 over tan x. Right? That's 1 over k. All right. And then they ask you for sine of x. Now, what is sine x going to be? Sine is defined as perpendicular over the hypotenuse. What is perpendicular? X is supposed to be in the first quadrant, right? X is acute. Perpendicular is k. So that's k over hypotenuse. We have already done this calculation before. Now that's helpful for us. Square root of 1 plus k squared. That's our final result. That's sine of x. Is that
Sir,
okay? Yeah.
sir, I couldn't understand the first one, tan pi minus x. How is it equal to minus k?
X is an acute angle. X was in the first quadrant. Think of, for instance, if you were to think in degrees, for instance, if x was 30 degrees, then what would 180 minus 30 be? That will be 150, and this angle would be in the second quadrant. In radians, we are doing pi minus x, pi minus that angle. That angle turns out to be in the second quadrant. Now, when we go in the second quadrant, since this angle is pi minus x, remember the angle on a straight line is pi. If this is pi minus x, what's the remaining angle? X. This angle is supposed to be x. And this is what we call a basic angle. X is the basic angle. And I just told you before, whenever the basic angle is the same, the magnitude of that ratio always is the same, right? The magnitude remains the same. So in this case, x and pi minus x, they have the same basic angle, which is x. So the magnitude of tan is going to be k. But since we are in the second quadrant, tan is negative in the second quadrant, we put a negative sign there because of that. Make sense? Is that okay?
Yeah, Yes, sir.
Okay, let's have a look at a few more questions. Two more questions quickly, and then we end. There is another one in the worksheet like this. Let's try this. This is question number 49 from the worksheet. So the previous two examples that we did, the angle in both of them was obtuse, right? Now in this was acute, sorry. In both of those examples, the angle was acute. Now in this question, it says theta is an obtuse angle. Obtuse means the angle is between 90 and 180. That means it's going to be in the second quadrant. Given that theta is an obtuse angle measured in radians and that sine theta equals k, find in terms of k an expression for cos theta, tan theta, and sine of theta plus phi. Okay, again, let's think of this right angle triangle. Where is this triangle going to be now? Angle is obtuse. So where is that angle going to be? In the second quadrant. It's going to be here like this. This is the angle that we're talking about. This whole angle is theta, obtuse angle. Okay, this angle is theta. Now we can make a right angle triangle here. This is the basic angle. Let's call this angle alpha, right? This is the basic angle. Now, what is the triangle going to look like? Sine of theta equals k. How do we define sine? It's perpendicular over hypotenuse. So we could write it as perpendicular over hypotenuse. K could be written as k over 1. So that means if perpendicular is equal to k, then hypotenuse is supposed to be 1. And from that, you get base. That is going to be 1 squared, which is 1, minus k squared, square root. So we have all three sides of this triangle now, at least their ratio, right? If hypotenuse is 1, then perpendicular is k, and the base is square root of 1 minus k squared. Now, of course, it's on the left side, so base is going to be negative. We can put a negative sign there if we want. Y is going to be positive. Now we can just write down these values. Cos of theta. What is cos of theta? It's the second, cos of theta is defined as base over hypotenuse. What's base? Base is this, 1 minus k squared, square root. That's the base. Hypotenuse, that is 1. So 1 minus k squared, square root, divided by 1. But then we have to think about which quadrant we are in. It's the second quadrant. In the second quadrant, cos is supposed to be negative. So we put a negative sign there. Okay, so this simplifies to minus into square root of 1 minus k squared. That's the value of cos theta. Similarly, we can find tan of theta. What would that be? Perpendicular, which is k, divided by the base, which is 1 minus k squared, square root. K over square root of 1 minus k squared. And again, we have to think about which quadrant we are in. It's the second quadrant. In the second quadrant, tan is also negative. So because of that, we put a negative sign here. Okay. And this simplifies to minus k over 1 minus square root of 1 minus k squared. In fact, that's already there. So minus k over square root of 1 minus k squared. That is tan theta. Any problem with this? Any problem with the first two parts?
No, sir.
No? What about the last part now? Theta plus pi. How would we do this now? Where is this angle going to be?
In the third quadrant, sir?
In the third quadrant? Are you sure? Third quadrant? Theta is already obtuse, and we are adding pi to that. So this is theta. If we add another pi to that, pi is 180 degrees, right? Straight line. This will go on the other side here. This is going to be pi, and the whole angle then becomes theta plus pi. So it's the fourth quadrant. It's not the third quadrant, it's the fourth quadrant. This whole angle is theta plus pi. Now, since we're adding pi to this line is a straight line. This whole line is a straight line, right? So using vertically opposite angles, we know that this basic angle is also the same. This is also alpha. And if the basic angle is the same, the ratio between the sides remains the same. These are similar triangles. If the basic angle is the same, the ratios are the same, right? Sine remains the same as before. Cos remains the same as before. Tan remains the same as before. It's just the positive and negative signs that change, right? So what is sine of theta plus pi? Whatever was the sign before. What was sine before? It was k. So it is still k. However, since we are now in the fourth quadrant, we put a negative sign there. So it's minus k. Basic angle is the same, so the ratio is the same as before. It's still k. But because of it being in the fourth quadrant, we have a negative sign with that. So it's minus k like this. Is that okay? This angle here is theta plus pi. Complete angle. Any questions on this?
Sir, in the exam, we have to write it in the simplified form.
In simplified form, what do you mean by that? These are already simplified forms. You can't simplify this any further.
No, sir, for part I, we have to write.
Yes. Yeah, so if we have just one here, then yes, we should write it like this at the end.
Okay,
Yes.
sir.
Although they would still accept this. This will be this will also be acceptable because it's equivalent to this, but it's just better to write it like this, removing that one. All right. Any other question on this? No? All right. Let's do one last question. After this, you should be able to complete this whole worksheet now. Apart from the graph questions, we will be doing graphs on Monday now, inshallah. Can I have raise of hands if you have mocks in March? Can you raise your hand if you have mocks in March? If you have any kind of exams in March? Okay, so only two of you. All right. I'm just thinking to do some extra classes in the first week of March, so we could get a bit ahead, and maybe we won't have to do too many extra classes in Ramadan. Then we can probably do some extra classes before Ramadan starts, and then during Ramadan we could just go on our regular schedule. So I was planning some extra classes in March, but then I realized it's going to be Ramadan, so I'm not sure how many extra classes are going to be possible. So we could make use of the first 10 days before it starts, before 10th March. So I would just advise you to keep in mind that during the first 10 days of March, we might have 2-3 extra classes every week. So right now we have 3 classes in a week. During the first 10 days of March, we might have like 7-8 classes in total. So maybe you can just keep that in your mind right now, so that we can try and end the syllabus a bit early and not delay it too much. Okay? Does that work for everyone?
Sir, in Ramadan, the
Yes,
start of
sir.
your P1 class is the Adhan for Maghrib for me.
Yeah, so the schedule is going to change as well. So from 10th of March, we are also going to need to change the schedule, because in Pakistan we have Maghrib at 6 right now, and by the time it starts, it's going to go up to around 6:30. So yeah, so it's going to be clashing with Iftar and also Taraweeh. So yeah, we need to change that. So I'll take input from all of you and see what time suits most of you during Ramadan. So I'll have to go with majority then, and also depending on which time slots I can do based on my schedule. And then if you can't attend all classes and you have to watch the recordings, then what I can do is I can maybe schedule some extra time with those of you who are missing classes. If you have any specific questions, you can ask those during those classes, during those extra slots that we can schedule at some point. But we will need to change the schedule in any case. 6 to so I have classes actually from starting from 6 till 9:30 almost. The 3 consecutive classes, P3, S1, and P1 that I'm doing right now. Then it's going to be P3, M1, and M1 and P1, and it's not going to be doable during Ramadan, unfortunately. So we would either need to do it maybe around 3:30, 4 p.m. onward, or maybe at night around 9:30 p.m. or 10 p.m. Those might be 2 possibilities. Or we could split some classes, maybe have P1 early and then M1 later. But I'll get your input on the possibilities that we have, and then whatever suits most of you, we'd have to go with that. And then if you are not able to attend some of those classes, you will need to, so I'll be increasing the frequency of uploading recordings, and I'll be uploading recordings more regularly then. So in case you miss a class, you can hopefully go through that in your own time, the same day or the same night. So I'll try to do that at least, so that in case you end up missing a class, you can get done with it the same day. And then if you have any questions, of course, we can schedule something for answering those questions specifically. Okay. How many of you are, in fact, let me not give you a time slot specifically, but let me just ask, how many of you tend to stay up late during Ramadan, as in until at least 12 a.m. at night, until midnight? Or maybe 1 a.m., 2 a.m.? Most of you. Okay, so that's most of you. Okay, so let me actually have a poll here. Is that possible? Okay, no. So if we have two possibilities, that we can either do classes in the afternoon. So let's say after Zohar. So the time slots are also different for all of you actually. So something I'm talking about time slots according to the Pakistan time. So let's say if you're able to do 2:30 p.m. in the afternoon as compared to 10 p.m. at night. So can you write in the chat box what you would prefer, afternoon or night, 10 p.m. onward? What would work better for you? Can you write in the chat box? Naima and Aisha. Rijal, okay, you've responded. Okay. All right. Okay, so most of you are saying 10 p.m. So we will see what we can do. I will give you the possible time slots then, and then I'll ask you which one you prefer, and then we can see what works for most of you, inshallah. Okay, but that's going to be after 10th of March. I think we would have like 2 topics left by then, not more than 2. Most of the topics we would try to cover before Ramadan, then inshallah. By doing some extra classes during the first 10 days of March, I think, because I can do that time because I'll have some more free time slots during the first 10 days of March as well. So I could probably use them up here. Okay, anyway, let's do this. Question number 46, we'll discuss that later then again, but I have a general idea about what most of you prefer. We can discuss that later again. Question number 46, it says, the reflex angle theta is such that cos theta equals k, where k is between 0 and 1. What is a reflex angle? What's a reflex angle? Does anyone know?
Greater than 180
Yeah,
and
so it's
between
greater than 180.
360.
Yeah, so reflex angle is an angle between 180 degrees and 360 degrees. That's what a reflex angle is. Which quadrants is that? No, reflex is not 270 between 270 and 360. Reflex is between 180 and 360. Okay, that's what reflex means. So if you were to draw it in quadrants like this, you could say it's either the third quadrant or the fourth quadrant. These are the 2 possibilities. Okay. Then it says the reflex angle theta is such that cos of theta is equal to k, where k is between 0 and 1. Okay, so cos theta is k, and k is between 0 and 1. That means k is positive. If k is positive, that means cos is positive. Where is cos positive? Cos is positive in the first quadrant, but we can't be in the first quadrant because we have a reflex angle. First quadrant is not even possible. We can only have third or fourth quadrants. Amongst these 2 quadrants, cos is only positive in the fourth quadrant. So that means the angle theta should be in the fourth quadrant and not in the third quadrant because of cos being positive, because the value of k is positive. Okay. So the first sentence is basically telling you which quadrant theta lies in. So they first told you it's between 180 and 360, but out of them, since cos is positive, it's only going to be fourth quadrant. All right. Now it says, find an expression in terms of k for sine theta. Again, we can do it the same way as before. Now we've done this a few times, so we can just do it directly without even making a triangle. Cos theta is equal to k, and we're in the fourth quadrant, remember. How is cos defined? Cos is defined as base over hypotenuse. And we can write it as k over 1. If base is k and hypotenuse is 1, then what about perpendicular? Base is k, hypotenuse is 1, then the perpendicular is going to be hypotenuse square, which is 1, minus k squared, and square root of that. That is perpendicular. These are all the 3 sides that we have in that triangle. Now it says find an expression in terms of k for sine theta. Now, how is sine defined? Sine is perpendicular over hypotenuse. That means square root of 1 minus k squared divided by the hypotenuse, which is 1. Which quadrant are we in? We are in the fourth quadrant. In the fourth quadrant, sine is negative. So we put a negative sign there. And that gives us minus square root of 1 minus k squared. And then we have tan theta. How is tan defined? Tan is perpendicular over the base. Perpendicular is square root of 1 minus k squared. Base is k. Again, we're in the fourth quadrant. In the fourth quadrant, tan is negative. We put a negative sign there. That's the value of tan theta. So we have found sine theta and tan theta. Okay. Now it says, explain why sine 2 theta is negative. So we know sine theta, we know tan theta as well now. We want to now explain why sine 2 theta is negative. Are the first two parts clear? Any problems with this? The first two parts? No?
No, sir.
Okay, what about the last part? Explain why sine 2 theta is negative.
Sir, as 2 theta, sir, क्योंकि it's in the fourth quadrant and sine is negative in the fourth quadrant.
Okay, sine is negative in the fourth quadrant. So that's why it's negative, but remember it's 2 theta and not theta. It's sine of 2 theta. We're not talking about theta. Theta is in the fourth quadrant. What about 2 theta?
Sir, it's basic.
Sorry? I'm sorry, I could not hear you. What did you say? Okay, so theta is between 270 and 360, right? Why? Because it's the fourth quadrant. If theta is between 270 and 360, what about 2 theta? We want sine of 2 theta here, right? What about 2 theta? Just multiply this whole interval by 2. 2 theta is going to be between 540 and 720. That's where 2 theta is going to be. Now, let's think which quadrant is that. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. Then we go back to 360 degrees. And then it becomes 450 degrees. And then it's 540 degrees. And then it's 630 degrees. And then finally, we have 720 degrees. 540 to 720. Which quadrant is that? That's third or fourth quadrant, right? Theta was in the fourth quadrant only, but 2 theta can either be in the third quadrant or in the fourth quadrant. Is that okay? Now we can say, since 2 theta is in the third or fourth quadrant, we know that sine is negative in the third and fourth quadrant. So you can say 2 theta is in third or fourth quadrant. Sine is negative in both these quadrants. Okay, sine is only positive in the first and the second quadrant. So no, it doesn't matter if it's the third or fourth quadrant, sine is negative in both of them. That means sine 2 theta is negative. Is that okay? You have to write both of these things. 2 theta is in the third or fourth quadrant. Sine is negative in those quadrants. These are the two things that you will need to write. Right? That is why sine 2 theta is negative. Is that all right?
Yes, sir.
Yes, sir.
Okay, so that's it for today. We will be doing graphs in the next session on Monday, inshallah. You should complete the worksheet apart from those graph questions. And then if you have any problems, we can discuss them in the next week. And hopefully next week we will be starting our next topic as well. Okay. All right. Allah Hafiz, everyone.
Allah Hafiz, sir.
Allah Hafiz.